Hi, everyone. Can you guys hear me?
Yeah,
Yeah,
we
we
can hear
hear
you.
you fine.
Yeah.
Yep. Okay, perfect.
All right,
So,
Ronnie, you're on. Share and
yeah, so let me get started. So I'm going to break it down into a little bit of what we do, who we are, and then a little bit background of about some of the use cases we are solving, and also a little bit demo of the product. So our company name is Tursio. For folks uh, who are wondering what the meaning of the name is, it's named after a family of bottlenose dolphins, which have the nearest intelligence as humans. So that was the motivation of behind the name. Our former name was known as Smart Apps. We are actually going through a branding change because we don't build apps. We just make apps smarter. A little bit background about the founding team. All three of us were at Microsoft. I was the principal GPM for SQL Server, and then I was the senior director in Azure, and then I moved to Amazon. I was leading all of their building ads on top of the Amazon platform, uh, and then general manager for Amazon Ads, and then left Amazon and founded our own company. Alec and she, they were my
I don't know, Ronnie. I think maybe y'all need a few more PhDs.
yeah, all three of us have our PhDs in databases and data systems. We are very, very focused on building enterprise grade applications on top of databases and data warehouses. And that's where our focus is. She and Alec have done the first petabyte shuffle in, so we are very deep tech inside of database engines. And then, so they did the first uh, database petabyte shuffle, which has been used in Bing, which is the largest data processing system in the world. Like when I say that, it's beyond Databricks, beyond Snowflake for one individual workload handling all of Office 365's optimization and data needs. So with that, I wanted to get started. So generative AI obviously has been a game changer with large language models. I'm not going to bore you with all of the things we do with LLMs. But the problem we see is foundation models have a fundamental problem of operating on top of enterprise data. So if you actually use any of these foundation models and actually try to use those models on top of databases and data warehouses for enterprise data, you require a continuous effort to fine tune the models. You run into scalability issues. It requires a constant supervision. And the accuracy is roughly in the ballpark of 50 to 55% range. The reason it happens is because foundation models have not been trained on top of the corpus of the enterprise data, and they do not know the nuances of the ontological representation of the data for it to actually give that accurate insights. There is no way the way you define churn is known by a GPT or a foundation model for it to make that native understanding. So at Tursio, what one of the first things we have done is we have built something known as a large data model, because your AI or anything is as good as the fundamental data, which is stored in the enterprise databases or the data warehouses. You need to make sure that your data layer is absolutely rock solid in the way you do modeling of the data. And when I say modeling of the data, you actually need to understand the different entities, the relationship between these entities. What are the attributes? When it means sales in X table, what does it correlate to being sales in another table? And all of that understanding has to be native. Until and unless you actually form that understanding, you will never be able to just blindly point a OpenAI or a GPT-4 model to the data to actually get your insights or get information from that data accurately. So what is the way we do that? And this is going to be a little bit, this is, I promise this is the most technical slide you'll see probably on the presentation, but let me take an example of how we do this today. So the first value proposition we do is we actually do not move any data around. Yes, you've heard that right. We don't move any data around from any databases or any data warehouses. So if you have a data in SQL Server, in Oracle, in Teradata, in Postgres, we look at the data, we look at the high level query level aggregates, we look at the statistics, we look at the measures, we look at the join history, and then we create small data models on top of the data. You cannot have one model that solves all the problem. It's never a way. So what we do is we create small data models which have logical abstracted view of the data stored in those data models. Now, once we create these data models, the way to create that data models is something we built proprietary. That is our proprietary tech. We have patented this. We have had several papers in Sigmod, in VLDB, publishing this research. And then we create these data models, and then we embed these data models only inside the vector DB. So now, if you look at any of the RAG-based approaches out there, it's not scalable. And the reason is because they're trying to embed every row from the database inside a vector DB. So what happens is if you have a 1 TB data in SQL Server, you land up with a 3 TB data in a vector DB like a VV8. Then you create a LangChain on top of that, and then you do your indexes and you try to retrieve your data, matching your questions to an embedding to what the embedding response would be. The reason it's not scalable is because your application is writing data constantly to your database. You have to constantly make sure that the vector DBs are in sync. And then you spend a ton of money creating those vector DBs and creating those indexes in place. Since we store only the data models inside the vector DB, it becomes a highly efficient system for us. We do not embed the entire row of the database inside the vector DB. The third thing is obviously we have a fast caching mechanism in place so that we know when a customer is asking a particular question, what questions to actually store it in the cache to retrieve the responses versus actually querying the database directly. And we also maintain and manage these pipelines. So as new and data gets written to your database or your data warehouses, the models are constantly hydrated and refreshed and up to date and kept up to speed. So all of this is a plug and play generative AI system. From an enterprise standpoint, like if you have SMBs, if you have large enterprises, they have a lot of data sitting in their database and data warehouses. They have built apps on top of that. They have built a lot of apps on top of that. And the first challenge which they do is they actually spend time modeling the data. So the fact that we can automatically model the data, we create the smaller data models, we store it in the vector DB. What we have pretty much built is people can ask business level questions on top of the database directly without moving any data around. And that can power the apps of the next generation. And since we do a lot of these computational reuse, our latency is less than 3 seconds for giving any query response back. If you just make a query to OpenAI or GPT, you would be looking at roughly around 30 seconds or 25 seconds for a response to come back with this complexity. So then the more the complex the data it is, the better it is for us. So we operate with enterprise customers who have like 40,000, 50,000, 180,000 tables. So if you are using a small like database with like say 5 tables, yes, you can use any of these Azure Copilot stuff. But the problem with those is you are actually moving your data outside your enterprises for Copilot to use. So the fact that we do not move any data around, we create a natural language to a query operator tree. And that query operator tree is engine agnostic. So you can run pretty much our approach on top of Snowflake, on top of BigQuery, on top of databases, on top of data warehouses, on top of any underlying compute underneath the covers. And we do not store any data. So that gives enterprises that flexibility of using us for any database and any data warehouse. So with that, customers ask, okay, what are our various deployment models? Obviously, we have our cloud native deployment model where we can deploy in this solution as a SaaS-based offering where customers and enterprises use us. And then where the database or the data warehouse stays completely within the customer's own resource group and subscription. And we are capable of deploying our entire product as containers within the subscription itself. So the benefit in that approach is their entire system runs within that private VPC network of the particular enterprise. That is for the SaaS-based customers. Few of our customers have a hybrid deployment model where they are like, okay, you guys take care of the AI outside my firewall. I do not want any of these LLM, any of the OpenAI stuff coming within my network. So we deploy our data agent, which will actually look at the data as it constantly gets written to the database and data warehouse, but the AI service and our admin portal remains totally outside. And I'm going to give a touch base a little bit about the admin portal and what it does in a minute. So that's the hybrid deployment model. And the third deployment model is on premises. We operate on top of high value data, whereas like there is enterprise structured data in databases and data warehouses, and customers want to have GenAI offerings built on top of that. How you deploy this entire offering on premises. So we have customers who are in tax, healthcare, who have this highly regulated industries has this requirement that, dude, I cannot make an outside connection to the world, deploy your entire product using the LLM, everything on premises. And I have a complete air gapped solution to actually do that. And we can deploy it in on premises and well. Well, everybody is moving more towards the cloud. We all love the cloud and we have a cloud-based offering. I have been a GPM for SQL Server, so I know that most of the high value data is never going to move to the cloud. They're going to forever remain on Oracle. They're going to forever remain on SQL Server. So we are making a conscious choices of having a solid, rock solid on-premises deployment as well for our customers. So what are some of the customer use cases and examples what we do? So we are like an enterprise search. You can think of us as sort of being the Perplexity on top of enterprise data. So customers can ask business level questions to us directly without the need of even having ad hoc reports created on Power BI or in Tableau. So they can ask questions like, what are the cities which have the maximum number of customers subscribed in the last 3 months? Then questions like business focused questions like what are the customers which have like a percentage decile change of subscriber growth in the last 3 months, right? And questions like this, which make sure that how do you understand this particular question which an enterprise is asking? How do you know that a percentage decile change means this particular thing? So we do this understanding of these key metrics for these enterprises, natively working closely with the customers to actually formulate this understanding. And then obviously the last, which is the sort of the most common use cases we see, is questions related to forecasts, questions related to cohort, questions related to anomaly. Like based upon the number of customers subscribed in XYZ city in the last 3 months, what is the forecasted number of subscribers in the next month? Imagine you asking the question in natural language. You get the response from the database or the data warehouse where the question is, where the data is stored in less than 3 seconds. I'll give you an example. So in both in Microsoft and Amazon, I have seen leadership only asks a question. I know that a lot of you are leaders on the call, but I'm going to say that people ask questions. What happened here? What happened here? What is the data? What is the KPI? Blah, blah, blah. So now, and the teams underneath are completely randomized by that. Like they ask a question and then 5 days later or 7 days later, they ask the same question again, but it's different context. The data engineer has to figure out, okay, where is this report? Land up creating like 400, 500 reports. It's just a nightmare. And the teams are constantly randomized. So what we are doing is we see 2 use cases. One is insight in for enterprises. Enterprises have the data. They create reports. They need something for their functional operational efficiency, like which helps them run the business, like churn prediction, churn detection, anomalies, whatever it is, and they want this information to be surfaced to their leadership or for their entire teams to ask these questions in natural language and get the responses. We fundamentally think that the entire reporting frame is going to disrupt in the next few years. Like these Power BI, Tableaus of the world, the way you create reports is first you have to model the data and then you can create a report on top of that. I think we can disrupt this totally with our tech. Like, why not? People is creating a report to answer a question. That's why is it creating a report in the first place? Then why not ask the person to ask that question natively? And then on top of that, they can get even insights on top of that, which they have to build a different algorithm like on top of Python or R or anything of that sort. The problem in the data science world is the data science world and the SQL world or the database world is completely different silos. See, imagine that you have all your text records in a SQL Server instance. Your data scientist comes, writes a Python, so he actually extracts the data outside your SQL environment, puts it on his laptop, writes the Python algorithm, and deploys it totally else. So your data fundamentally leaves the secure boundaries. The purpose for which you are storing the data is defeated in that purpose. So we are saying, let's bring them closer together. Let's create the model and let the users ask the questions. So your data scientist right now can build the models natively inside the database regime itself, making the scoring and making the security highly efficient as well. So that is pretty much. I don't know if my screen froze for a while. Can you guys still see my screen?
Yeah.
Okay.
Got it. Not frozen.
Okay. So we feel that this, in order for you to do a reliable intelligence from your businesses, you need a combination of your large language model, which is obviously the natural language understanding of the data of your question, and you need a combination of a data model as well for you to provide you with that reliable intelligence. Since we create the data models, we cannot hallucinate our responses. If you ask a question which we don't know, we will not give you a response. And we have the feedback loop trained in so that we know the questions we could not answer, and we can understand back to the enterprises like, okay, what does this particular KPI mean? Like one of our customers is like, what were the licenses? What were the cola licenses which were sent in the last 3 months? Right? We don't know what cola is. It's a cost of licensing agreement for that particular domain. If you type this question in GPT will give you Coca-Cola responses, right? And this is where it gets fundamentally so important that you understand the domain and the ontology of the data you're operating on to create the data models first. And then you create the data models, and then if you're asking a question, it maps to one of these data models which we have created in with our query operator tree to retrieve the responses from the database and data warehouses respectively. So that is the reason we are highly accurate, because we cannot hallucinate our responses, because everything is stored as data models which we are responding from, which is from the data. And with that, so let me actually share with you guys a little bit demo of this particular product. Can you guys? I don't know for. Okay. Can you guys see my screen still?
Yeah.
Yep. Okay.
Yeah,
So
we see
this
it.
is so this is the Tursio sort of like the platform. We are sort of the enterprise search. So you can say that customers ask questions like show similar records with identical SSNs, right? You type in a question, you have, this is a data quality, classical example of a data quality issue. They say, okay, first row ID and second row ID. So you click on this particular question. It actually runs natively on top of the databases. It actually tells you the rest of all the records are identical with this particular customer, but only phone number is missing. So they want to make sure that before they are right, as soon as their apps are writing data to the database and the data warehouse, they want to make sure that that warehousing is clean, because their apps, their marketing apps, everything runs on top of that. So we are able to understand anything on that sort. So, or show similar records where postal code differs at most 1 digit. Like questions like this, and then you click on that, and then you can actually figure out all of the responses from where this particular thing happens. So what we are trying to do is, this is just an example of in a data quality space where we see examples of profiles with different SSNs. Like, and you can go on and on and on questions where you can see that, okay, this profile, you see that there is only a typo of 8690 to 8609, but the rest of them is for the data engineers to see whether this is a duplicate record or this is a total different record, but the address of the person is the same, the city is the same, the country is the same, the date of birth is the same. Probably they use different email addresses, but one is the official phone address, maybe one is a cell phone number, but the SSNs are awfully similar. So that is one sort of an example. Then we have customers who use us in, say, show the top 5 operational managers seeing the most vulnerabilities in SA Windows with 60 days SLA. You type in the question, off you go, you see a pie chart, and then we also expose the corresponding model underneath the covers. You can see that here It's not just a text to SQL, because it doesn't work that way. What it does is we create highly optimized indexes on top of the database, and we create those queues, which are pretty much the data models, from where we are giving the responses back to this particular customer. Then we have customers who have a lot of toll road data. So they ask us questions like manned versus, let me just try, manned versus unmanned transactions. Now, the question is, manned means somebody paying by cash, unmanned means somebody paying by credit card. What is the transactions happening in a particular toll booth? So their scenario is, during the summer months, do I need to staff more agents in the booths or less agents in the booth? So when you do the manned versus unmanned transaction, it actually goes over the period of time. You can actually see that during the summer months, people are traveling more on the road, so they need to staff their toll booths with more people. You don't want to have, like, you see where the toll booths dynamically address change, like 2 cash, 3 credit card. You don't want just 1 cash, because then it will be so backed up, because people are traveling and paying more on cash for those particular road scenarios. And then you can actually apply more filters on top, like manned versus unmanned transactions in 2018, 2017, whatever you want. The response comes back, and then you see a time series chart with just that data for that particular year. And then one of the things is grocery sales, right? Like, so customers use us like for planning demand for certain particular items. And then when you click on demand, you see not only just a time series chart of the data sets, but you also see a forecast. You can see, okay, based upon this, how many curl leaves do I need to stack up to meet my forecasted demand? So we have customers right now in demand planning, food and beverages, tax, construction, healthcare, media and entertainment. Customers asking us for predicting what their campaign optimization algorithm would look like. Like, when am I making losses? What are the top keywords I need to run my campaigns on? Alert me whenever I'm actually missing, when it's 10% over or 10% underutilized, anything of that sort. So, but before I wrap up, I told that I'm going to mention a little bit about the admin portal. So
Hey,
we fundamentally,
hey, Ronnie,
yeah,
can you show the Pro Painter one real quick?
yeah, I can do that. Yeah. So yeah, I'll do that one as well, Marty. So
And
this
while
is
you're
an
talking, while you're talking about that, talk about how this plays in with MDM and governance and Marty, maybe you want to join in kind of what you were thinking on that.
Yeah, let him bring this one up real quick so we can
Yeah.
show that one. Because one of the projects he's working on is a master data management one because they have full access to the database. They've got full access to the historical data, the query logic, the whole 9 yards. It can help build your master data management catalogs from a database perspective.
Brad, are you on? I saw his name, but he may be in a meeting.
I am. I got to drop in 4, but I'm listening.
What do you think about this?
Intriguing so far. I'd be interested to see maybe the use case of the data catalog specifically, if there's an example of that.
Yep. And then we'll maybe we can schedule a one-on-one on that one.
Yeah,
I
sounds good.
definitely.
This
I'll
is
send you an
more
invite
for,
today.
Tommy, this falls under more for a data stewardship kind of
Yes.
stuff where you actually want to improve data quality.
Exactly right. So that's where we're heading. Okay, so all right, why don't you show that, and then I'll schedule something with you later. I owe you a calendar invite anyhow later, so I'll just send it. Maybe we'll do both.
Yeah, I think Marty was referring to these Pro Painters, which is a AI powered smart code, where how painting companies or localized construction industries are using us. So if you look at any painting service or any professional service like landscaping, flooring, roofing, whatever you want, you have a multi-step form you have to fill today. You have to go figure out, okay, how many square foot houses I have, whatever I have, and then fill it in, and then you get a code, and then they schedule somebody to come over. 20 people, 15 people come. You find out who is the best, probably with the reviews, and this is a time-consuming problem for this industry. So this is a company which says that I need to paint my paint 4,000 square feet house exterior, right? And you can go on and on and on, filling the details. Tursio. And sorry, 1, 2, 3, 4, 5, 6, 7. And what this does is this is the AI powered smart code generation, which actually allows customers to type in the codes and get their response, and even for sales agents to become much more efficient. They actually have the work scope. It has house exterior, all inclusive, all vinyl windows inclusive. What is the scope of the work? All of that. What is the money? How much money they need to deposit, and move on. You just received your fastest quote ever in the world, just like that. So, and that is that is an industry which is like highly been using us, more on the construction segment. And this is just a real life production environment, which I just showed from our customers of ours. So, yeah, so I think that's all I had, but I would love to hear feedback, comments.
Coming up, questions? Wes
Sure.
had to go. I'm sure Wes would have probably asked 15 questions since it's around the data. Anybody
Can you
got
hear me?
questions?
Can you hear me?
Yeah,
I
Paul.
switched headsets.
Yeah, Paul.
I'm gonna have to drop for 20 minutes, but I definitely want to learn more, Ronnie. That was your setup on the left brain, right brain, and the importance of the model.
Mhm.
That I've been pushing that rope.
Yeah.
I need help. So
Yeah, we can help you. We can help you because I
all
feel,
right.
yeah, we can absolutely connect. Let's connect offline, Paul. If you have my contact, I think
Yeah,
Marty.
we'll regroup for sure.
Sure.
So
I'll be
I have
back in
a
about 20
question.
minutes.
Okay.
I have questions. So
Oh, please.
you mentioned that you can actually go to a specific, I mean, across databases. Is it like kind of federated? If I ask a
Yes,
question,
it's a federated search.
it's federated. So if I have data in like
Mm-hmm.
kind of Databricks, Snowflake, I mean SQL
Mm-hmm.
Server,
Mm-hmm.
and maybe 3 other databases, it
Mm-hmm.
will actually go and look into all of these databases and get me the answer. Am I correct?
Correct.
So it's federated.
Yes, it's federated.
Oh.
It's a federated search happening across. So just like in the database, you can have 40,000 tables, which is a federated search happening once you. So what we have built is an understanding of the natural language to breaking the natural language down into smaller fragments and mapping that fragments to different models. So you can have a model in Oracle, you can have a model in Databricks, you can have a model in Snowflake, and then how you actually regroup these models and create the query operator tree. At the end of the day, any compute engine is an operator tree running on top of that data. So we have built this natural language to the query operator tree, which fundamentally works on top of variety of different data sets. We process structured data right now because we coming from that, we know that this is a high value space. Obviously, you can do PDFs, images. PDF images are fine with the unstructured data, but we want to focus mostly on structured data. So we are venture backed right now, and that is just the area where we want to just double click, and because we know that there is a high value there.
Beautiful. I like one word answers. That's usually the best answer. Yes. That's usually.
I could add a little bit. Can you just repeat? You're working more with structured or unstructured data?
Structured data.
Got it. Okay. Thank you.
We operate on structured data, David. The reason is because we feel that this is a high value space, and you see a lot of these AI wave going on in images, videos. There is nothing on structured data because it's a tough problem to solve. Like if you look at who is our nearest competitor, ThoughtSpot is probably, but in ThoughtSpot they also don't do the modeling dynamically. They require you to create the models first, yes, and then on top of that you can ask questions. Like if all of this text to SQL, it's like I don't know what's going on because people are thinking English in terms of SQL and writing English in a SQL-like statement and getting SQL back. Why not at that point just write the SQL? Like we are like, just ask the question in the most natural language possible. We will actually figure out how to use LLMs, how to use the data models to get that data, because that is the natural way people ask questions. And the way of our approach of creating the data models, we are in a unique position to only do that. right now. I can send you guys a VLDB paper on the Sigma paper we had, which shows how and the approach we are doing it. And we actually did a benchmarking test. We are not supposed to do benchmarking, but just with Azure because it was our X team. And we know that out of 26 questions, they could answer 2 questions correctly. 24, they could not respond. I don't know what the balloons are going on, but and then out of us, we could answer all of the 26 ones. They and accurately. So out of the 2 questions they could only answer, the rest out of 24, 14 of them they couldn't even respond, and the 10 of them were incorrect responses from the databases, which is a huge problem for enterprises.
Mhm.
So and that is the reason we show a table out there. When you're asking a question, we are saying, boss, this is where the table, this is what the data looks like. This is your table. You are asking a question, you're getting the response in a table. And these are the records where it matches. So it builds that trust. And then they can also view the SQL query if they want. They can copy paste the SQL query, validate it, or do whatever they want. And just imagine a CIO going into a board meeting. He asked the engineer, like, okay, blah, 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 what was the revenue in the last 3 months? The data, he said, oh, 40 million. But probably overnight, it went up to 41. And right now, there is no way for him to know. So he can ask just a question in a mobile, and we are having a mobile presence where they can just ask a question. Okay, what was the sales, blah, 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 just before the board meeting? He gets 41 million. He just reports that to the board. So it's just a new form of how we are thinking about enterprise apps being built for the next generation. So we are entirely API based. Customers can just invoke our APIs inside their application. The fact that we do not move any data, they just can embed this search inside their app. Like customers like Redfin, they have a lot of these drop downs, like 25 square feet house, 4 bedroom, 3 bath, blah, blah. And then you click on search, you get the response. Why not let the user ask the question in natural language? Show me all the houses in less than $800,000 in Washington with 4 bedroom and 3 baths. And you get the response. With a school rating of 7 or school rating of 9, you get the response. And that's where these apps are being AI powered through the search capability which we are providing.
So I have 2 more questions. Tommy, are we in
Thank you.
hurry? Then I can skip. I can reach out to him later on.
Not at all. Ask away.
So first question is, you talked about you only are extracting metadata. By model, you mean metadata. I mean, I understand. So now, typically, the quality of the data, one of the major issue is multi-use of the same attributes. And unless and until you scan the real data, you will not be able to kind of come up with 100% accurate data because you don't know how the table is, how the columns or attributes are being used. And also they may be used for multi-purpose. So how do you take care? Isn't that the hallucination that we are talking about? It's a different form of hallucinations.
So you're mentioning a good point. So I said that we look at table level aggregates, measures, statistics, joins, query history, and we also look at physical, like the value of the. So we have a read-only access to the data. So we just do not say that. So from the query history and all of this metadata, you can create a based model. But you're absolutely spot on. Unless you have a read-only access to see the physical values, how do you know that this is date of birth and this is an SSN? Both of them may look just the same, but that doesn't mean anything unless you understand the ontology of how this is defined. And every country defines date of birth in different ways. So that ontological understanding is something which we do looking at the data. So yes, we physically do look at the data, but we do not move any data. We do not move any data outside the system. We look at the data and create everything in memory. So once the customer is typing a question, everything is memory till the customer wants to explicitly save it as a table back into the database or the data warehouse. So everything is happening in memory. There is no data movement happening. So we pretty much what we do, Ketan, just for your ease of understanding, is this natural language question to the operator tree. We create that model. We create that SQL model. And then we give that back to the customer. The customer executes the model on their data set and gets the responses. So the push down computation happens in these compute engines itself. So we do not have a storage engine. We do not have any compute running. We are compute agnostic. So we are not like Databricks that we have our own Spark compute or Snowflake with their own compute. We are compute agnostic. We have patented this ability of understanding a domain and ontology, mapping a question to that fundamental operator tree for that engine. Then we give the query and the customers execute those queries natively within their front end, or they want us to execute the query, we execute the query and send them back the response. So your question may be, who is going to take a performance hit? It's the storage cost of these customers going to high. Since we are storing data models, which is a highly optimized view of the data, we do not store the entire data set. So the footprint of increasing storage cost is fractional. So it's really fractional. The models are really very small, logical abstracted view of the data which we store.
Yeah, so and the second question was regarding the forecasting that you were talking about.
Yeah.
So I'm 100% not sure. How are you just forecasting based on the actual data, or I mean, because forecasting require a lot of variables.
Yes.
I mean,
so we look at the feature attributes on the database itself. So we have in that planned demand example I showed you, we are running an ARIMA model on top of the data. But the fact is every enterprise has their own models they have built. What we are saying is we are showing you an example of how you can ask a question in a natural language. You hit the right places from where to pull the data, and then you forecast on a decision point. So imagine this is a 3-dimensional space. You can forecast on a region, you can forecast on a product, you can forecast on a quantity, you can forecast on a SKU. Every time you're not going to create, like, your forecasting model has to be tuned for all of this. And we have that understanding underneath the covers. But if a customer has their own models built, we can actually plug that in for generating that forecasting response. But all of this right now, it's an auto-ARIMA, auto-regressive model which we have trained and which we have deployed in that example I showed you.
All right, and in fairness and everybody, I'm gonna stop it here because we're 10 minutes behind.
Oh,
But
sorry.
why don't no, we're fine. It was great. I've got Marty, remind me to ask you how this is gonna play in with, how does this integrate in or play with Quark, because I know I'm gonna get that question. So, but I think we need to do the same thing with like Quirk and a couple of the other ones. I think we need to schedule another one that's just specific to this, so we can get into more details. All right.
Sure. Yep.
I'll get with you. I'll get with you and Marty, and we'll get something on the calendar for the next couple of weeks where, maybe we do an hour and we can have some follow-up questions. This is intriguing as hell to me. Like, I see the power of it. All right.
All right. Thank you, everyone.
Thank you. Appreciate you.